to you. It's a bit strange, of course, but we're getting used to speaking at a distance, and it certainly has some advantages. I'm speaking to you from the West Coast, where Colin comes from. This is the traditional territory of the Musqueams, Tsleil-Waututh, and the Squamish peoples. And you can actually see UBC here, and Howe Sound over on the left, and Burrard Inlet over towards Vancouver on the right. So that's where UBC is based. I must say, having been in Canada for 25 years, one of the things I've learned is that there's the East Coast and the West Coast, and then there are all the flyover provinces in between that the coasts are really important for what we do. And reflecting also on having worked here for a number of years and having worked with ecosystem management since, well, it's been 30 years now or something like that. One of the things that I've been wondering about is, especially when I started out with this, was how long time is it going to take before the way we manage the ocean is really based on ecosystem-based approaches? And I thought 30 years ago that, yeah, it might take 10 years. And we're still dealing with that question 30 years later. And it's been really slow. One of the reasons for that is it's one thing to do the science to get ecosystem modeling up and understanding and figuring out what you can do with them. But it's quite a different story if you are to actually use it as part of the management. And that's what this talk is all about. And what I'm going to do is to give you a little bit about background about Ecopath with Ecosim, really brief, and then talk more about how it has been used as part of the management process. And I'm going to be covering from single species fisheries management up to ecosystem-based management. And ecosystem-based management is where we have multiple sectors involved. That's roughly what I'll try to get you through during the next half hour. So it's going to be a very quick review. But let me start off by just mentioning that this is a messy picture. This is a food web, which is of a quite typical, slightly complicated state Mediterranean basin that Pierre made. Ecopath with Ecosim is the most widely used ecosystem model. And indicators of that is that we are logging about 8,000 users or more than 8,000 users every year. And if you look around, there are more than 1,000 publications. I think I have 900 in my collection, and I know I don't have everyone. Which, by the way, if anybody would like a copy of those, just send me an email. The approach is used for a number of things. It's been used for 35 years. Actually, the last conference I went to is the one you see here in the picture down the lower right corner, our 35th anniversary. And you can see from it that the title was Making Ecosystem-Based Management Operational. And indeed, the talk that I'm giving today is based on my opening lecture for that conference, because this is really the key now to ecosystem-based modeling. How do we make it operational? How do we get it in so that it's actually being used in the management process? That's what I'll give you examples of. But EWE can be used for many things. If you're just looking at this food web from before, that's really good for getting an understanding of what's in an ecosystem. So it's descriptive, and that's the starting point for ecosystem modeling. Once we have that, we can then build and look at dynamics. But the first part there is ecological descriptions and extracting indicators. So there's a lot of work on that. And I'll say out of the 1,000 papers, more than half of them, or something like that, would be my guess, deals with are more descriptive, describes the ecosystem, the indicators. But a really important use of these approaches is to evaluate trade-offs in management. that's where it really becomes interesting. They are also increasingly being used to predict impact of climate change, so we have more and more work going in that direction. And interestingly, something I work quite a bit with is environmental impact assessment. That's something that when you start building infrastructure, big infrastructure projects, for instance, that's something where it really is important to have an understanding of the ecology. What harm do we do when we build these big projects? So I'll be talking about this later on. And spatial planning is another big area for this kind of work. What's behind it is three components of it's a modeling framework that has three major components. The Ecopath is the mass balance food web model that you saw represented before. We can pass that on to a module that does temporal simulations, and if needed, to another module that does spatial temporal simulations. And it can be quite complicated, but it's still pretty accessible, and it's quite capable. Then there are some additional aspects to this modeling framework. One we call Ecotracer is from contaminant tracing to look at, for instance, isotope. I'll give you some examples of this, and increasingly for work on microplastics. And there's quite a bit more. One interesting thing there is that there's plugins. If we look at the structure of the modeling interface, one really important part of it is that the computational aspects are hidden away in a core. Hidden away, not more hidden away than it's not a black box as such. You can use it as a black box, but you can also go in and work with the source code. But importantly, it's separated completely from the scientific interface, which the default scientific interface is a spreadsheet type thing with graphs and so on. But it can also be, we have examples of using, for instance, a 3D gaming software as the scientific interface. It's completely separated. And it's also the core, the computational core is also completely separated from the data source. And really neat thing about this is the plugins, which are snippets of code that makes it possible to address all three layers. So one doesn't have to use the distributed model. One can make one's own and do, for instance, repetitive analysis or of some kind, looking at uncertainty or so on. So there's a lot of development going into this. Indeed, the development is focused on, well, it's distributed quite a bit in the sense that we have a consortium that deals with EWE. It's been around for a decade and it has 29 institutional members at the moment. And that's the organization that looks after things like the anniversary every 5 years and a number of other things. And that's all the background I'll give you now about the modeling aspects of it. So we're going to be focusing much more on how it's used for making ecosystem-based management operational. And I want to stress here what I mean, or make it clarify, I should say, what I mean by operational. That's going beyond the sheer scientific, the scientific work that we've been doing for decades. When we're talking about operational models for marine resources, they have to be routinely and regularly provided. So something that is done every year or every few years and being updated all along. The approach has to be vetted and verified. That means there has to be review process that has gone through, has looked at how does this model behave, what does it do, what are the constraints, what are the advantages, and so on. That has to be really cleared. It should be continuously updated, and importantly, it should be used to inform the decisions. It doesn't mean that it's the only model going in or the only approach going in and used as part of that decision material. That's hardly ever the case that we only use one model. Wherever possible, we use more than one model. Indeed, one of my favorite quotes, that's quoting myself, is, models are not like religion. You can have more than one. and in brackets, and you shouldn't believe them. You really have to question the outcome from models, from any models. In the management here, making the models operational, another thing is that they typically, the questions that are asked are typically tactical, short-term questions about how do we do about management of this species in this bay in this year. That's the kind of questions. That's, by the way, also one of the questions why it has been really difficult for ecosystem modeling to get into the management. That ecosystem models are much more suitable to addressing strategic questions. That's the kind of questions about where do we want to be with this ecosystem in 5 years or in 10 years from now, and how do we get there? What are the options and what are the trade-offs? That's really where the strength is of the ecosystem models. And with models, again, you can have more than one, and you often need to have more than one. They are for different purposes. Generally, what we do there is we ask the question first, and then we decide on what model to use next. So it's about trade-offs. It's about trade-offs in the ecosystem. What happens when we go in and we impact an ecosystem, be it through fishery or be it by going in and changing the habitats by, for instance, building infrastructure. What happens in the ecosystem when we do that? And it also has consequences. That also has consequences then for humans. What happens with the various users of the ecosystem and the people that whose livelihood depends on the ecosystem? How do we evaluate that? That's what ecosystem-based management is about, balancing trade-offs. And you can see up here in the top left corner that I put EBM with a little f in bracket. That's because it's ecosystem-based fisheries management. Or ecosystem-based fisheries management is one of the steps towards ecosystem-based management. So let's look at how EWE contributes to making ecosystem-based management operational. And I picked up this framework here, which was developed by NOAA, the sort of U.S. National Oceanographic and Atmospheric Administration, that, among other, has a part that deals with fisheries, the National Marine Fisheries Service. And they have these 4 levels, going from single species to ecosystem approaches to fisheries management, to ecosystem-based fisheries management, and then on to the ecosystem-based management, the multi-sectoral. If you look at these, the single species management is, well, that's what we've been doing for 50 years or more. Ecosystem approaches to fisheries management, and look, those symbols that you see here are something you see on the rest of the presentation. They go back there. There you still focused on one species, so it's an ecosystem approach to fisheries management. But you may be considering climate, habitat, and possibly predators. Typically also predators. Predators come first there. That's what's most often is involved. When we get to ecosystem-based fisheries management, then typically there are multiple species involved. So it might be multi-species model, it might be ecosystem models, and they thus considers predator-prey interactions, and often also climate and or habitat is built in. Ecosystem-based fisheries management includes all of the below and other sectors as well. So let's look at how ecosystem models are included in this. And I'm focusing this on EWE, and part of that reason is, as mentioned before, that it's a really widely used approach, the most widely used approach for this, and that's what I know about. There are other approaches, other interesting approaches, and there's a good cooperation between ecosystem modelers, including, this is a diversion, but for instance, there is one of the interesting things that happen around modeling climate change is that there are model intercomparisons projects. And these model intercomparison projects make sure that the models are comparable. So when IPCC or IPBES needs models or model output to evaluate impact of climate change, they look for models that have been vetted through this process of model intercomparison projects. And we have a fish model intercomparison project that have a number of different models that we run with the same drivers, and we evaluate how they react to the same questions to make the models more comparable. So that's, there are interesting things going on. I'm just in this talk here focusing on EWE. So among others, because that's the only approach that really covers everything. So the general rule is to, when you are, again, as I mentioned before, when you are dealing with a research or policy question, that comes first. That's what you want to ask, not what model you want to use for it. But the rule is you always use the simplest model that can address the given policy question. More complicated model means you have less predictive power. So the simplest model is the best one. And for single species assessment, that's the typical questions we're using. That is what we do with single species management. It's single species models that are the simplest model to address those questions. You can do it with an ecosystem model, but it's often an overkill. However, even for single species management, there may be conflicts between species, and that can lead to trade-offs. To address those, we go to the next level, the ecosystem approach to fisheries management, which it's a single species model typically that includes additional aspects, notably predation. There can also be environmental. That's included. And I have an example here from a US Fisheries Management Council down in Florida and our Gulf of Mexico Fisheries Management Council, developed by Dave Jagaris. You see here a really important species over on the right, striped bass. And this plot here is a biomass of striped bass with high biomass down the lower left corner and low biomass up in the upper right. There are two black lines. The lower one is the target. That's where they would like to be with the management. And the upper one is the threshold. The threshold is where it gets red. That's where you don't want to go above. You don't want to be up in that low biomass zone with striped bass. Striped bass is really important for recreational fisheries. And you can see here there's a trade-off. The analysis are looking at what's the impact of the fishing pressure from Menhaden. Menhaden is a small oily fish that's used for reduction purposes. It's the biggest fishery in the US, maybe, well, in continental US at least. I think pollock up in Alaska may be bigger, is bigger here. The Menhaden fishing pressure, the key prey for the striped bass, the more you fish, as you move out on the right, on the x-axis, the more you fish there, the less striped bass you can fish. So that's this trade-off here. And that's what the ecosystem approaches to fisheries management can add to single species management, evaluating carefully really important trade-offs between two species, a prey target species and its predator. What is the impact there? What happens? Next level is ecosystem-based fisheries management. In the US, National Marine Fisheries Service is now implementing it based on a framework like you see there on the left is described by Howard Townsend and colleagues there, which in essence is the right part of it is quite a bit like it used to be. There is stock assessments being done based on research survey data, commercial fisheries catches, other biological data. Those stock assessments then go on to a plan, to a team review and a scientific committee review before they end up with the Fisheries Management Council. And there's public and commons involvement in this process here. When they do an ecosystem-based fisheries management, they add to an ecosystem model, ecosystem indicators that may go in and then, for instance, produce an ecosystem status report that may or may not, there's no arrow here, but there should have been an arrow between that and the stock assessments, because very often it's used to develop, for instance, predation mortalities, variable predation mortalities that can be then fed to the stock assessments and then into a process. That's happening increasingly. But instead of giving you examples of this, I'm going to go east to the European Union's common fisheries policy. Now, the common fisheries policy was the laughing stock of fisheries management a few decades ago, until a decade ago. And it has really changed because the European Union has gotten a much better handle on how to do fisheries management in recent years. It's difficult when you have that many independent countries, big fishing nations, and strong national interests to get things sorted out, but they have moved a lot. And now the two notable aspects of the common fisheries policy is that they are working with multi-species maximum sustainable yield as a management objectives, and they have also introduced a landing obligation, which is a nice way of saying you're not allowed to discard fish at sea anymore in the European Union. So discard ban is not a word for landing obligation. So that's a couple of interesting aspects where they really need to understand the ecosystem effects of this and the trade-offs that it has for the fishing community. So they consider the species interactions. You'll forgive me here for not talking about Canada, but Canada is way behind. I'm not. Yeah, it is. CFAS is the old lab up in Lowestoft. They're looking after the British, the UK, no, the English fisheries management. It's largely done there. CFAS developed a North Sea ecosystem model, and they did that to look at the multi-annual plans options for multi-species, multi-fleets interactions. They use a management strategy evaluation plugin for EWE that they developed there that did exactly what they wanted to do. It's a really neat approach for how to work with this management strategy evaluation. This is the downside of a review. I could talk about the whole talk could be about management strategy evaluation, which is right now the holy grail of fisheries management. There's an ecosystem version of that, and this is what they use for this. So they use this model to evaluate mixed fisheries, multi-species effects, including the biological, economic, and social consequences. And some of the conclusions from that was you can't get the maximum sustainable yield of fish at that level that gives you the maximum sustainable yield, as the FMSY, of all the species all the time. There are trade-offs between the species, and it simply isn't possible. You can get closer to it if you use a range instead of using one target for this species has to be fished maximum at this level or as close to this level as possible to give us most yield out of it. If you put a range around it, and when you do that, it corresponds to Ray Hilpon's pretty good yield. That you may not be fully at the maximum sustainable yield, but it's okay if you're close to it, pretty good yield. And that actually makes it much more, makes it possible to manage multi-species in many cases, fisheries, mixed fisheries. One lesson from that is also that if you are close to the upper part of these ranges, there's more risk of closures of the fisheries, and which is something we certainly want to avoid as much as possible. And also, if you are being more careful, you're fishing at the lower ranges of the maximum sustainable yield, you get more biological interactions. It's more pronounced in that case. Very often, when working with this, we're seeing that high fishing pressure replaces predation mortality. So if we fish hard on the menhaden, for instance, the ones that are impacted by that will be the prey. So we can go out and outcompete predators. That's part of what happens. And if we fish less, well, those biological interactions becomes more pronounced. And hence, what this points to is there are trade-offs. There are trade-offs between rebuilding the resources and fishing. And those trade-offs impacts the ecosystem, but they also, to a very large extent, impact the people whose livelihood depends on these fisheries. And that's something we have to remember. That also has to be remembered when doing something as introducing a landing obligation, a nice word for a discard ban, which they've done in Europe. And, that's very popular because people can really see the waste. If that cod being thrown up there in the upper right corner is dead, looks pretty live. If it's dead, well, it makes no sense to discard it, of course. And it used to be so that very strong discard policies in the EU, they had to discard fish. Crazy thing would be, for instance, there used to be so when fishing in Norwegian waters, the boats were not allowed to discard. But when they came to Europe, they were not allowed to have the other species on board, so they have to discard them right at the border. So this is a really difficult one. This one where there's a public opinion saying, oh, we shouldn't discard fish. But it really makes it very difficult for fishers to maintain livelihood under those conditions. There's been a number of studies here using EWE to assess these consequences. The general findings from that is that the landing obligation, the discard ban, that results in higher biomasses in the sea, which is this is the key target of getting this in. It does that when you have a quota system because of choke species, which basically is the boats will have a quota for the various species. And as soon as the quota of one of those species have been filled, they have to stop fishing. And the result of that is lower profitability for fisheries. The hope with introducing this landing obligation is that it will lead to more selective fishing. And that is happening to some extent. There's one thing that is absolutely certain is that fishers are smart. Full stop. If there is a way of keep continuing fishing and making the fishing more selective, they will find that way and they will work actively to do it, which speaks a lot for a good cooperation with fishers and fish organizations. So there's a lot of studies around that. And I'll move on now to the next point, the one trade-offs between sectors. So here we are talking about all those things that are listed up there. If we can see them, I have something in front of them. We're talking about fisheries, development, energy, ecotourism, oil and gas, conservation, marine resources, sanctuaries, so marine protected areas, agriculture, all the different aspects. Energy is a really important one when we talk about, as you will know, on the East Coast. So here we're seeing EWE being used for getting ecosystem indicators, evaluating ecosystem services, and then various aspects that relates to trade-offs with energy, extraction or shipping or that kind of questions. I'll give you some examples of what it's being used for. Starting off here with indicators. Indicators are really important because when you look at an ecosystem, think about it, you're getting all on this, or even not, you don't even have to look at the ecosystem, just look at the ecosystem model, and you're sitting there confronted with so many species, so many parameters, and so many things happening that you can see that play God, you can increase fish mortality there and put in a protected area here and see what is the consequence, what are the consequences of this. But what do you do with all that information? Summarize it somehow, and that's what indicators do. And that's something that's really well developed in European Union. They have developed a marine strategy framework directive. This directive has a number of descriptors. That's what you see there in the table. So there are these 11 descriptors, and then they have a number of criteria and a number of indicators. And this is standardized. It means that all countries in the EU, at least those that have water masses, marine waters, have to report every year about the ecosystems and what the state they are in based on these descriptors. And to make those descriptors, to get those descriptors, ecosystem models that summarize what happens in them are really a pretty good tool. And EWE is being used to quantify this. It can quantify the majority of these descriptors. And importantly, as you see here on top right, it's being used on all the regional seas in the European Union. So they have evaluated in the European Union that, and they are using it quite extensively in this process here. And you see in the lower left corner, by the way, this is the European, the Ministry of Department, what they call it. Oops, it's not department, it's not ministry. Come on, environment. It corresponds to a Ministry of Environment, but it's just a European Union level. The Environment Directorate is the word I was looking for. The Directorate of Environment is really powerful. You know, fisheries is a little side issue in many ways compared to the environment. That's an area where it has a big bite. This environment, it has power in many ways that we don't see as much in the fisheries world. So good environmental status, that is what they are aiming for with the marine strategy framework of the EU. It's really an interesting one. And to evaluate that, they have in something they call the Joint Research Center, which is up in northern Italy, up here, a place called Ispra. They developed a modeling toolbox, which has a number of models that can talk together and which evaluates these various indicators that are used to evaluating or to describe the good state of the good environmental status of the ecosystem. So there are really interesting things happening around indicators and what can we tell about what's happening in these ecosystems. That directs what's going to be happening on pollution control, on what activities to allow, and many, many other things that have direct consequences for management. That's ecosystem-based management. Ecosystem services is another thing. Here are some examples of EWE papers that deals with that. Not far from all of those are included into management, but they influence it. There's a lot of, when you get into ecosystem services, there's often that link from the service to the implications of it is often not well formulated. So you may say here, oh, mangroves are really important because of the impact they have on, say, the nursing grounds for small fish, and they also protect against typhoons or whatever may be happening. Quantifying that is a big issue, and that's one area that ecosystem models can help with, certainly about the impact of nursing grounds. When it gets to storms, that's another kind of modeling, other type of models. So that's important too. And it brings us to energy. So there are examples of modeling impact of oil spill, which is not directly used for management, but it's the kind of things that impacts whether these infrastructure developments are allowed to go ahead, what are the consequences, and how do we prepare for it? And then not the least that part, what kind of mechanism do we have to have in place to be prepared when the next accident happens? On energy, another big question is, what do you do when oil rigs and pipelines get to the end of life? So there's been a lot of work there, especially in the UK, in the North Sea, on what do we do? Do we leave them in place? Do we remove them? That's a big multiple billion-dollar questioning, and ecosystem models are useful for evaluating those impacts. Another area that I work quite a bit with is related to nuclear incidents. I don't know why they call them incidents, but it sounds better than accidents, doesn't it? So Fukushima, for instance, NOAA was really prepared, of course. Nobody expects the Spanish Inquisition. Afterwards, we modeled what was the impact of this. But one aspect of this was that the International Atomic Energy Administration realized that we need to be prepared next time it happens. So jointly with the French Nuclear Safety Institute, they organized some workshops to look at developing toolbox for what to do next time it happens. And no wonder the French were involved, by the way, because France is really heavy on nuclear energy. And we know when this next incident happened, it's going to be impacting it's going to be by water. And one of the first things going to happen is that, what will happen is the seafood production from that area is going to be shut down. So what do you do in that case? Where do you sample? What do you sample? When can you say it's safe to open again? What protocols should be in place, and how do we model that? And how do we do it quickly? That's one of the questions that has been impact there. Will Walters, who's a faculty at Penn State, is one of the key people who work with this, even though his Penn State job is much more focused on what happens inside the reactors. What happens if something goes wrong is something he's an expert on. And yeah, so it's kind of a neat area. There are a number of applications related to that. Wind farms, oops, that's the next thing. Wind farms are really big in many places, especially in Europe. A number of places in Asia too. And there are quite a number of evaluations of what are the ecological impacts of those. And they are important for when, as part of the process for where to allow and to what degree and on what conditions the expansion of development of especially offshore wind farms. That's another area. Wave energy, something they work quite a bit on Scotland, and there are some projects related to that as well. And shipping, what is the impact of shipping is another really that's another area where there is a lot of interest now, especially with regards of, from our perspective in marine underwater world, it's mainly related to vessel noise, marine mammals, and starting to be also impact, to look at impact on fish species. So modeling impact of vessel traffic is another area that's being explored quite a bit. Protected areas, well, this is what Ecospace spatial model was built for. There are a number of projects for that. And one, they can lead, for instance, as in this top right corner, to traffic pattern, traffic light evaluation, which I won't go into details here, but you'll notice that there's no green, 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 green all the way down in the various scenarios that were evaluated, because there are trade-offs when you build these. It's certainly not a holy grail to put in a marine protected areas. It has implications for fisheries and for other things. So understanding those trade-offs, that we'll use the models for. So quite a lot I have here for 40 minutes talk, but I'm almost done. We've got 4 or 5 slides left. And we actually get into some of the really important areas here. Environmental impact and assessment and infrastructure development. It can be down here by Mississippi, where because of dams, the loading of sediments has decreased from 400 million tons per year to 150 million tons per year. The sediments are not being brought out, and that has consequences. You can see there in the lower right picture, all the red areas here, that's land loss because of the lack of sediments coming out the river. So these areas are flooded that used to be land 50 years ago, or 70, 80 years ago. So this has consequences, and what are the ecological consequences of that and what can we do about it? That's something that Kim Demutsets and colleagues have been working with or are working with down in that area. Infrastructure development in the Amazon is another one. They're talking about going from building a lot of dams. I can't remember how many it is, but all the red dots here are dams that are planned or proposed. What are the consequences of that for the indigenous people? That's one of the big questions that have been asked. I worked for the last 8 years, so 7 or 8 years on this activity here. What's the ecological consequences of constructing a 2 square kilometer container terminal close to one of the major salmon river estuaries in the world, the Fraser River? To evaluate that, we did a lot of monitoring. There was a lot of monitoring, 35,000 hours of monitoring in this small area has been conducted because it is requirement for the environmental impact assessment that there is a good understanding of consequences and what happens there. All right, I saw a hand, 2 more slides and we are done and can take questions. Marine spatial planning, a really interesting thing there. Yeah, EW is being used for spatial planning of various kinds. There's something called the Marine Spatial Planning Challenge, which is a kind of a gaming environment to evaluate alternatives or consequences of marine spatial planning. It's a pretty neat activity. We get people together, group of people together that may be doing it a real thing afterwards, but this is like a flight simulator for marine spatial planning, where you can go in and you can go through the process. So for instance, in Europe, it would be different countries coming together to do planning that's been done for the North Sea, for the Baltic, and a few other areas too. That is, you can, if you're interested, you can look up MSP Challenge. You can even download a version and arrange a local workshop with it. It's pretty neat. We did that at the Ecopath 35 conference. So finishing, what's required for contribution to ecosystem-based management and to actually get the models to be used? My key points are, it's a complex activity and it has to be implemented and evaluated very carefully. So there are some demands for the level of how it's done. Really important aspect of that is that models need to be challenged by data. There has to be data behind this. It has to be quite clear how it relates to data, how well it does, and how it works. And it has to be what Jason Link calls vetted and verified. There has to be a clear review process for how it's being implemented for this to work. And I say at the end here, business as usual for how we manage fisheries is not designed to consider trade-offs. That's kind of an important message, that we need to consider trade-offs. Trade-offs, we see here on the West Coast how our DFOs management here is really conservation oriented, and they close fisheries without any, I would say, consideration for the social economic impacts of that, even on a very poor without, maybe we shouldn't go there. But I really think that we have to evaluate those trade-offs. The consequences for people whose livelihood depends on fisheries is something that should be part of it. It's conservation in a world where we explore resources that should be called for, and models, ecosystem models, can evaluate those trade-offs and should be used for that purpose. All right, I'll stop here and let's see how we do about questions.
All right, well, thank you. you, Dr. Christensen. Yeah, we'll take questions now. I saw there was a hand right away. And so I'll call on you and you can unmute yourself and ask a question. And if anybody has a question in the room, it'd probably be better if you came up here and asked it so he can actually hear you, especially with the mask on. So I believe, let me get the list going here. Oh, there we go. I don't see the hand anymore. Yeah, does anybody else have a question?
Question.
Yes, Abe.
Can I say it? You just say it to him.
Sure, I'll repeat it.
When we cover it up. Thank you for the talk. It was very interesting. In your point about considering trade-offs, one thing ecosystem models can't do is prioritize what the trade-offs are, right? You can consider them, but it can't say which ones we should give priority to. I'm curious, like, just to hear your thoughts on the process of that next step, how we actually assess priorities in payments.
Gonna have you come up here. This is your field. If it's about gear design, I'll understand everything you said. Yeah.
Sorry about that. Can you hear me all right?
Yeah, now much better.
Okay, cool. How do you take the next step from considering trade-offs to actually prioritizing what is a good and bad trade-off, right? Like if an ecosystem model can show us what the trade-offs might be, where's the next step to say this, and this is how we're going to prioritize X over Y? And can you talk about that process a little bit?
We face that problem every day, all the time, and I can give you some examples here from BC, since I know this side of the country best. You'll hear about it in the context of killer whales, where salmon fisheries are being shut down, even though the most likely explanation for what happens to killer whale has to do with the Chinook salmon, has to do with pinniped predation. That's an area the DFO does not want to touch on the West Coast. So the only handle they have is to shut down fisheries, even if fisheries have next to no impact on those populations because they already are shut down. Ecosystem models can make those trade-offs clear. And I think it's our responsibility as scientists to objectively do those analyses, to demonstrate what are the trade-offs and what are the explanations for what happens in the ecosystems. But we have to do that. Then it has to go on to a management body to deal with the consequences of that. And when I was talking about DFO before about how they tend to, here on the West Coast, much more than on the East Coast, to be conservation first really being the driver. I think they lack consultation with communities as an important aspect of this, and also with science in the sense of being willing to understand that there may be what was it called it inconvenient truths aspects to this. I find that willingness to take that on really a big problem. So yes, we should, as scientists, explore what's the science. The decisions about what to do should come at another later level. Yeah. Yeah.
Do we have any more questions? Still have 9 minutes. Oh, you see a hand. Oh, wait, where's it at? 2. Oh, I see 2. Oh, yeah. I was looking for something yellow. All right. No, I'm going to unmute you, Dr. Cadigan.
Okay, can you hear me?
Yeah.
Yeah, thanks for the talk. You mentioned that this idea that you can't achieve the single species maximum sustainable yield on a level from all species simultaneously, and that's I guess an idea that's been around for a long time. So in Canada, it seems like DFOs kind of they have this precautionary approach to fisheries management, and a big driver is keeping species above limit points. So is there any, I'm wondering, is there any work on what are like ecosystem-based limit reference points? I mean, is it possible to keep all species above kind of single species limit reference points simultaneously? Or are you aware of any work in that direction? I seem to recall that there was a MIGS model done on the Flemish cat where, they had, my recollection was they were having, thinking that you couldn't keep, all species above these, what they had, what were established as a single species limit reference points.
It is difficult to do that. Again, here, one of the things that DFO has been doing is to introduce a weaker stock policy, where they basically close down all the fisheries if one stock is below the limit. It's probably not possible to keep everything above those limits at the same time, at any given time. What seems to be working best is the way that the lowest tough example for the North Sea is managing the multi-species fisheries, multi-fleet fisheries, by having a range of FMSY values, developing what is a pretty good yield in Ray Hilborn's terminology. The consequence of that may be that there are species that go below the limit for periods. Can we live with that? In the US, the Magnuson-Stevenson's Act says, no, you can't do that. And that's also, in many cases, the interpretation here. And I really think that's one of the things that we need to discuss with the management. I think we have to be able to, there has to be an understanding of why it happens, but the discussion has to be there about what are the implications of this? Does that mean we shut down all fisheries, which is what's happening now?
All right, do we have any more questions? We have 5 minutes left. Andres.
Yes, thank you very much, Doctor, for that presentation. I'm wondering, you mentioned, and I agree that Canada is a little bit behind in this kind of topic. So I'm curious of how do you think that can be solved, and what are the next steps that can be taken in Canada to implement that kind of approach that you're talking about?
DFO is talking the talk, and they've been doing that for years, but the progress has been very, very limited. DFO is a big monster organization, and I would not mind at all if I would love if we could rethink the way DFO runs. let me compare to the European Union. We really need to, not European Union, to United Nations. We really need to have an organizations like the United Nations. It's not well functioning. We can't do without it. And you must imagine if we could rethink the way we're doing the United Nations, that'd be fantastic. I would say exactly the same for DFO, we ought to rethink the way that DFO is functioning. I think that's part of it, and it's not happening. You know, it's much more pronounced on the West Coast than on the East Coast. On the East Coast, at least there's owner-operator system, and there's a lot of consideration for small-scale fisheries. The West Coast has gone just in the opposite direction, and so that's one aspect of it, combined with it being very much focused on conservation, and the only handle they have is closing fisheries. That seems to be what's happening. So reinvent DFO.
That's a good way to end the seminar. Yeah, thank you so much for being with us, Dr. Christensen. I really appreciate it.
Can I just say, and I work with DFO. And trying my best to and it you know, in a very corporate way. We're doing a lot of work on shrimp fisheries right now with DFO and with the industry as in between there. And we need to have that cooperation between academia, fisheries organization, and DFO, not just DFO being the almighty God that puts out directive. Involving academia and the fishing industry into those decisions, I consider really, really important step for evaluating, balancing the trade-offs that are and have to be in management. We are using these ecosystems. It's great. The resources we get from there, the food we get from there, and other services is really important for us. So how do we do that best? Involving academia jointly with DFO and fishing industry is a step in the right direction. That's really how I see it. So I'm not talking for a revolution. I'm arguing for a cooperation that involves those three partners.
All right, that's perfect. I think we're out of time now. Yeah, if you can, if anybody can come next week, we're going to have Dr. Thomas Quinn from the University of Washington talk about predation by bears on salmon, ecology, behavior, and evolution. So yeah, so thank you again for joining us, and thank you so much for your presentation.
Thank you very much.